This is What's New in Docker. This is Vivek. He tweets at the V Saraswat. And usually at Docker, he builds roadmaps and herds cats. So Vivek, this is all you.
Hey everyone. Welcome to the first breakout session of DockerCon Europe. Glad to have you here. My name's Vivek Saraswat, as Ben mentioned. I'm a product manager on the Docker Enterprise Edition team. I tweet at the V Saraswat. I'm going to talk to you today about what's new in Docker. So here's our agenda. We're going to cover 3 different sets of things. We'll talk about Docker Enterprise Edition 1706, recently released. We'll talk about Docker Community Edition 17.09 and the feature sets in both. And then finally, we're going to deep dive a little more into the Kubernetes integrations that you saw during the keynote, demo a couple of things we didn't quite show in the keynote, and talk about our overall strategy and planning around the Kubernetes integrations. So let's start with a quick overview of what the Docker editions are. So we have 2 major types of editions at Docker. We have Community Edition and Enterprise Edition. Community Edition, or CE, is the free do-it-yourself option for both developers and ops. It doesn't include support, but it includes stable releases for operations folks, as well as monthly edge releases for developers who want to test out new features. On the enterprise side, EE is a paid Docker subscription that includes support from Docker. It's stable releases only for production use, enterprise-grade features such as security, management, and operation. And then outside of the features within the platform, it's a certified partner ecosystem, including rich integrations from infrastructure on the southbound side and applications and plugins on the northbound side. And EE is really what we recommend for production and modernizing traditional applications use. So let's talk a little bit more about the EE stack. So as I mentioned, it's really the containerized platform for building a modern app supply chain. It's an integrated orchestration, security, and management platform. The stable releases have a minimum of 1 year of support and maintenance. That means that any major security patches and hotfixes are backported to all supported versions. And the support is enterprise-grade and includes 2 different options. One is same business day from 9 a.m. to 6 p.m. in your local region, or business critical, which is 24/7 every day of the year support. And then again, in addition to the features in the platform, we have Docker-certified infrastructure, containers, and plugins. Docker-certified infrastructure are things like the OSs that we run on top of, including RHEL, Oracle Linux, SUSE, Ubuntu, CentOS, and recently Windows Server 2016. And also the certified clouds we run on top of. We have additions for Azure and AWS with more on the way. On top of Docker EE platform, we have certified plugins and containers. Certified plugins are integrations such as storage, networking, monitoring, and logging that enhance the platform. And then certified containers are applications that we run and have tested against the Docker platform that come from third parties. So that's kind of what you get out of the box with Docker EE and what's in the ecosystem. And then a quick look at the components within Docker EE. The first is the Docker engine. This is what we all know and love. This is the container runtime that allows you to take images and turn them into containers. And it includes basic tools for orchestration, how you schedule containers against a cluster, networking, volumes, and plugins. The other parts of the Enterprise Edition stack are Docker Universal Control Plane, or UCP, and Docker Trusted Registry, or DTR. UCP, Universal Control Plane, that is the application and cluster management platform within Docker EE. So that's what allows you to string together a group of nodes, whether they're running in multiple environments or multiple OSs, and schedule workloads against that group of nodes, have a common management UI, as well as features related to security and scalability. And if UCP is what you use to manage your apps and your users, DTR, Docker Trusted Registry, is what you use to manage your images. So this is the registry where you push and pull images on both the ops and the dev side. And there's a series of tools that allow you to build a secure supply chain, and we'll talk a little bit more about that. And of course, all of this runs on top of multiple environments. It runs in the cloud, it runs in virtualized on-prem environments, and it runs in physical bare metal environments. So let's get into some of the new features. We'll talk first about Docker EE 17.06. So really the focus in EE in this release was around 2 different use cases. One is what we call scalable multiple architectures. So how do you build a Docker platform across multiple architectures, whether it's different types of infrastructure like x86 or mainframes, or whether it's different OSs like Linux and Windows. The other major use case is what we call the secure supply chain. How do you build a tool set that brings you from a developer building their applications all the way to ops running the apps in production with a series of security phase gates in the middle to ensure that only the right apps are going on along the pipeline and that only the right people have access to those applications? So the first feature that we designed for 1706 is the mixed Windows and Linux clusters. So in the current version of, or Docker 1706, the latest version, you can run x86 Linux managers, but your worker nodes can be Windows Server 2016 nodes, they can be Linux x86, and also very recently they can be IBM Z mainframe workers running Linux. So you can now manage both your Linux and your Windows applications from a single console and deploy the workloads to the appropriate area. What's important to note here is that all of the EE features like role-based access control are back. LDAP or Active Directory integration for your users, the 3 S's that Benjo talked about during the keynote, signing, scanning, secrets, works on both Windows and Linux, and works on both x86 and Z mainframes. So no matter what kind of environment you're running, you're getting the same security and scalability tools across all types of infrastructure. Let's try that again. So let's talk a little bit about some of the features that are within the platform beyond the infrastructure. So access control is a key component to any enterprise-grade solution. Your idea is who has what level of access to a given set of resources. Now, we've had RBAC in the platform since UCP 1.0, way back in 2015, but we've actually built a bunch of really cool enhancements in the last release. The biggest one I want to talk about here is the ability to create custom roles. So a role is a set of permissions on what a user can do to a resource. For example, I can view a resource, but I can't actually deploy one. I can edit the resource, I can deploy it, but then I can't edit the containers midstream. I can deploy containers, but I can't deploy volumes or a specific type of volume. So in Docker E, we used to have a couple of default roles, which we still have, like no access, view only, full control. But what we've added since is the ability to create custom roles. The feedback we've gotten from customers is, all of my roles don't necessarily match the ones you have. We have very specific permission sets for specific groups. I have a security team that only is able to access specific types of resources. I have an ops team that needs to access everything. I have a dev team that needs to access only a subset of API permissions. So with UCP 2.2, which is a part of the EE 1706 release, you can create custom roles that meet the needs of your organizations. You can set whatever permissions you want. So looking here, you can see that there's all the various Docker API permissions. There's a much longer list than that. Container operations, network operations, volume operations, secret operations. Every single one you can choose and decide which ones you want a given set of users to access. And again, you can select those permissions from the entire set of the Docker API. So it's one thing to be able to set the permissions that people have in your environment, but what if you have a bunch of different teams and you want to only make sure that each team has access to a specific set of physical resources in the cluster? So the previous access control is talking about logical isolation. What about physical isolation? We built a feature for that in EE 1706 called RBAC for nodes. The idea here is allow a certain subset of users, teams, and orgs to deploy within a subset of nodes in your cluster. So again, let's say you have a group of dev teams and you only want them to touch nodes 1 through 5. And then you have an ops team and a security team and you want them to touch nodes 6 through 20. But you wanted to make sure that those teams can't see each other's nodes, don't even know that they exist and can't deploy to them. That's what the RBAC for nodes feature does. So now you can basically have multiple teams within the same cluster providing physical separation and isolation. And it uses the same access control principles as you would to provide access to a container or to provide access to a volume. So there's a couple of different use cases you can do with this beyond just physical isolation. You can prevent noisy neighbors. So a noisy neighbor is when you have multiple applications running on a node and one application perhaps wasn't built as well as it should without constraints, and it takes up too much resources and starves everything else out of the cluster. Using the RBAC for nodes feature, you can make sure that a team's access only includes a specific set of nodes, so you can isolate their resource usage to those nodes and thus isolate the noisy neighbor effect. And then the other major thing you might find is the ability to meet compliance and regulatory requirements. So for example, HIPAA is a pretty common compliance for the healthcare space. So you could isolate those workloads related to HIPAA to specific nodes to ensure that only the right people are touching them and only the right qualities are met for those nodes. Another big feature which we talked about in the keynote is this idea of automatic image promotion. So the idea here is using Docker Trusted Registry, you can promote blessed images from one repository to a different one in the same DTR. So let's say you're a developer, you're building your Hello World application, you push your Hello World dev build to your personal repository, and you make changes as necessary, and there's no strict access control, just you have the ability to access that. Now you want to move it to the dev repo, and you want to ensure that there's some level of stringency around the access control in this repo, because the dev repo can pull to the dev clusters. So you set tag equals latest as the policy you want to use. That means that, okay, only the latest version of the application will be allowed to promote to the dev builds. Now you want to run it in QA or prod, and you want to make sure there's no vulnerabilities. So you set a policy saying no critical or major vulnerabilities when you're going into the QA or prod repo. Once you have the policy set, using what you see on the lower left-hand side, there's a bunch of different options you can set. Any image that goes into that repository automatically gets promoted to the next repository if it meets those policies. So this is really powerful. You can really build a secure supply chain from dev to QA to prod. And as you go from one level to the next, you can increase the level of stringency and increase the level of requirements for the policy. And this really allows you to create that phase gate to make sure only the right applications are making it to the right level of infrastructure in your environment. So those are some of the features in Docker EE 1706. Again, we talked about scalable multi-architecture, and we talked about secure supply chain related features. What are the things you need to do in order to run Docker in production? Let's do a quick overview of some of the new features in Community Edition 17.09. So there's a couple of cool things that have happened in 17.09. The first is the support for compose format v3.4. So a couple of nice things in this version, the ability to specify a health check start duration. So when you set up a health check, you can say, I want to wait X number of seconds before I activate the health check. This is important if you have an application that you think might take a long time to come up. So you want to set that health check so it doesn't immediately start and then give you a red error. So that's an example of what's coming in that. Docker service rollback. This command allows you to roll back your configuration of your service. Let's say you do a Docker service update to scale up the replicas or change the image, but you're finding for whatever reason that's not working. Docker service rollback will allow you to immediately roll back to the previous configuration and thus make sure that you can double check to see everything's okay. This existed in the API, and now it has an explicit CLI command. The third is overlay 2 over AUFS as preferred file system. So overlay 2 has come a long way over the last several months, in the last year. And operating systems like Ubuntu 16.04 now use that as their default file system. So within Docker CE 17.09, we've made overlay 2 the preferred file system. Next is --ch own added to add copy and Dockerfile. So this one's been a long-running pain point. If you've taken a look at Moby tickets recently, this one's been going around for a while. I see a couple smiles in the audience. You know what this one is. So this allows you to change ownership of files that have been added or copied within the Docker file. So previously, if you set user to something other than UID 0, you'd be okay on the user side. But then when you add or copy a file, you'd have to painfully go through and make the changes. Now, straight from, you can just add the --sch own, and you can actually make that change up front. So I know that one's going to make a lot of people happy. Final one I want to talk about is experimental support for Docker Trust. So maybe you've heard of our cryptographic signing technology, Docker Content Trust, which is based off of the Notary open source project. This allows you to cryptographically sign an image with your personal key to indicate that this application is ready to run, that it's in the right shape. Right now in the CLI, there's a couple of hoops you have to jump through in order to sign an image. In order to make that easier, we've added a bunch of new CLI commands that allow you to directly view all the signatures on an image, revoke signatures on an image, or sign them directly. So this will make it a lot easier for you to make use of the Content Trust feature. And then when you actually run in a production setting, you can use those signatures in order to enforce whether an image is allowed to run on a cluster. So that's experimental for now, but we're looking forward to bringing it into the platform. And we'll talk about that a little more in the keynote tomorrow. The other important PSA I've been asked to give is that starting with this release, the Docker service commands create, update, scale, rollback, they all use the non-detached mode as default. In previous versions, they use detach. If you want to keep that behavior, use the --detach command. So that's what we've got for Docker EE and CE. Let's talk a little bit about the Kubernetes integrations. So we walked in the keynote how we're adding Kubernetes support across the board in Docker. Let's dive into that a little more. So I'll talk a little bit first about what our Docker EE integrations look like. So the big announcement, of course, that we showed and demoed is that Docker EE is going to include Kubernetes support. Now, if you've used Universal Control Plane in the last couple versions, you'll actually note that there's already 2 orchestrators running in the platform. There's Swarm Kit, which allows you to do Docker service commands, and then there's a so-called Classic Swarm, which allows you to do Docker run commands, which create individual containers rather than a declared service. So we already have some experience within the Docker EE platform of running multiple orchestrators on the same nodes or on the same cluster. And now we're adding support for Kubernetes. So the idea here is bring Kubernetes online in the cluster, take advantage of features that are in Kubernetes, things like pods, batch jobs, blue-green deployments, horizontal auto-scaling. And for a user, it's all about choice. You get to choose which orchestrator you want, which feature sets you want. There's things that are not yet supported GA in Kubernetes, like production-ready Windows and IBM Z support, so you can use SwarmKit for those. And Kube you can use to get the features that you want. And the very important thing is that all the Docker EE features that are built into the platform, things like DTR, the private image registry, things like security scanning, content trust verification, user management and access control, and automated policies, you get all that on top of all of your applications. Doesn't matter whether it's Kubernetes, doesn't matter whether it's Swarm, doesn't matter whether you're Docker running a container. You get the full EE feature set across all orchestrators. That's the really important thing that we're trying to bring into this platform. So how does it actually work? Under the hood, it's today's universal control plane with an additional orchestrator. It's a multi-orchestrator configuration. So Docker EE sits on top. The control you send requests to the EE UCP controller, and then depending on whether it's a kubectl command, Swarm API, or classic Docker API, it'll forward it to the appropriate orchestrator, classic Swarm, SwarmKit, or Kubernetes, and perform the necessary operations. And then you get the feature set that's included. You'll be able to allocate nodes to each orchestrator, so we'll have UX features that make it simple to set some nodes as Kubernetes and some nodes as Swarm. Very importantly, this is the vanilla CNCF kube. There's no wrapping, as Solomon mentioned in the keynote. It's the full kube. You've got kubelets running on the nodes and the kube controllers running on the UCP managers. It is an opinionated stack. So if you've ever taken a look at kube, you need to include a networking driver, for example, in order to wire the nodes together. At Docker, we're all about batteries included but swappable. So we include a batteries included networking and storage. So we'll have CNI compliant storage, and then we'll have storage, CNI compliant networking, sorry. And then we'll have storage, which allows you to use Docker volumes to attach to Docker pods. So it is an opinionated stack, and we're looking at also providing plugins for networking and storage as well. From a features benefit standpoint, there's support for the Docker and Swarm API. There's support for the Kube API. So all your existing apps continue to run. You can build new Swarm apps. You can build new Kube apps. And like I mentioned before, the EE features like LDAP Active Directory, access control, the 3 S's, all of those work directly across every orchestrator in the platform. So, So what does this mean in principle for an ops team actually trying to run a cluster? Our goal, our vision is really to have a single platform that's shared by many teams. So let's say you're an ops team, and that means that you have several different application teams that are running underneath you, that are running on your IT infrastructure. Maybe you have one Java dev team that wants to use Kubernetes-based applications. Their developers want to build against the Kube API. Maybe you have a Java dev team that's using Swarm and wants to build Swarm applications and modernizing their traditional apps. Maybe you have a .NET dev team, and they've got to use Swarm in order to build their applications. The goal with Docker EE is in one cluster, you can have all of these groups deploying across your nodes. So using the RBAC for nodes and the access control features, you can segment out so that the Kubernetes team is working on a subset of nodes. The Swarm Linux team is working on a subset of Linux worker nodes. And the Windows team is working on a subset of Windows worker nodes. So this is the goal. One platform, many teams, the same general EE workflows, but whatever application workflows you want to use underneath the hood, Kubernetes, Swarm, or otherwise. From an upgrade standpoint, we expect this to be pretty simple. You get the new version of UCP, you get Kubernetes. So an easy upgrade from existing EE cluster. Once you upgrade the newest version, Kubernetes is there. Beyond sort of a typical engine restart, no additional workload downtime required during an upgrade. And importantly, no cluster configuration migrations required. It just works. You add Kubernetes workloads at your own pace. All your existing swarm services or containers continue to run. Creating new services or new swarm services or containers continues to work. But all of your new workloads can immediately start leveraging those Kubernetes features. This is the vision we have. You get the orchestrators you want, you get the features you want. So now I'm going to show you a quick demo of what we've built. And I wish I could make my offering the demo gods, but we don't have a Lego set in these rooms. So what I'm going to do is I'm going to show you, now I'm not going to copy the workflows you saw in the keynote. I'm going to show you something a little bit different. I'm going to show you a Kubernetes YAML deployed through the UI. So here is our, good, it's working. Here is our UCP cluster. So if you've seen UCP, there's a couple of differences from before. On the left side, you can see that we have a couple of different tabs. So Kubernetes and Swarm are now under different tabs. Swarm allows you to go to Swarm-based services, networks, volume, secrets. Kubernetes allows you to go to Kubernetes resources, controllers, load balancers, etc. And then importantly, shared resources allows you to see things that are shared across both orchestrators. So containers and images, under the hood, Kubernetes and Swarm are both just using containers. So these are shared across all orchestrators. And then nodes are, of course, shared across everything as well. In the middle, this is a small cluster. It's just one manager and 2 worker nodes. And then you have information on both your Swarm and Kubernetes workloads here. So now we're going to deploy a Kubernetes YAML file directly from the UI. So I'm going to go to the Kubernetes tab, and I'm going to hit Create. And so if you have familiarity with Kubernetes, YAML files are how you deploy everything. That's how you define out the various resources you're going to use. So what I'm going to do is I'm actually going to upload an existing YAML file. And this is sort of one of the typical YAML file samples that are shown on the Kubernetes website. So this is a Cassandra YAML file. So Cassandra is a pretty well-known database. You can see it's using a replication controller. It's one of the first kube controller types that works similar to a Docker service. It allows you to create multiple replicas of pods. Pods are what you schedule, the unit of scheduling in Kubernetes. It's one or more containers. So you can schedule pods on your clusters. So this is just replica 1. It's a pretty simple deployment. I need to select a namespace. Namespaces are how kube organizes resources. Importantly, in UCP, access control will be done through namespaces in kube. So you'll set access to namespaces. So I'll set default for now. And this is not a compose file like we showed on screen in the keynote. This is a Kubernetes YAML. So I'll create that. And you can see very quickly it created the Cassandra replication controller. The pods might take a second to come up. There, the pod is up. And so UCP bubbles up from the Kubernetes API, all the different information that it provides, including the spec for the template. Now, that itself actually goes and creates a pod. So take a look at the pod here, and you can see the various data that's in this pod in terms of what it creates. But under the hood, it's all just a container. Kubernetes is creating containers, and we can use UCP features to actually take a look at that container. So I'm going to go to the container tab right here. And I've got a bunch of random containers running in my environment. So let's quickly just search for the Cassandra ones. And I'll get 2, because this pod created 2 containers that are co-located on the same host. So let me just pick one of them. And under the hood, this is just another container. You can see it's got all the various information about the resource as a container. But you also get the memory usage and CPU, which there isn't a whole lot being used right now because I just put it up. But you can also access and manipulate it just like it would any other container. So I can go ahead and go to the console. And this allows me to exec straight into the container from the console. And so I can run sort of any standard commands that I want here, a PS or an LS. We're inside the container manipulating it. Whether it's a Swarm or Kubernetes container, you can take a look directly from the UI. You can also view the logs directly from the UI. So if I click here, we can get a sense of the logs that are coming from that container. So if you're a current UCP customer, all the workflows you're used to using in Docker EE, you can continue to do that with your Kubernetes containers. You can do all the monitoring and management directly from the UI, or you can do it from the CLI. So, and just to show you that it's real, I can in fact go to the CLI, similar to what we showed before. So in Docker EE, you can create what's called a client bundle, which gives you your certificates and allows you to point your client to the UCP cluster, but using the certificates of your deployment. So I've already created this bundle. So I'll go to my terminal. I'm inside the bundle right now. You can see there's a bunch of different files here, the PEM files that are created. So all I'm going to do is source env.sh. This sets my cluster to the specific environment. And you can see that it set me to the UCP cluster, and it's made me an admin, so it knows I have access. So you can do a quick docker node ls, and this will tell you the amount of nodes in the cluster. This is in US West Amazon region, so it might be a little bit pingy. We'll see what happens. Here, so you can see that we've got the 3 nodes in my cluster, one of which is a manager, but I can also just run a kubectl get nodes command. And what you'll see is you're going to get assuming this works, you're going to get the exact same nodes in your cluster, but as Kubernetes CLI and Docker CLI. And you can take a look at the workloads that you've built. So I can do a Kubernetes get pods, and I can see the pod, or I can just run a Docker PS because they're all just containers on the hood, and UCP doesn't care which set of APIs that you use. So now you can see all the containers that are running, including the Cassandra container that I just created. So there you have it. With Docker EE, we just showed a demo of how you can deploy a kube YAML file directly from the UI. You can access the manipulator containers from CLI or UI, whether they're from Kubernetes or whether they're from Swarm. Okay, so that's a quick overview of what you can do with Docker EE. Now I'm going to turn it over to my coworker David Gaggio, who's an engineering lead at Docker, tweets at dgaggio, who's going to talk to you about some of our CE Kubernetes integrations.
Oops. Thank you. So, did you like the keynote this morning? So there are 2 things in the C Kubernetes integration. There's Docker for Mac, Docker for Windows, and there's the stack thing, the support for stacks. So Docker for Mac, Docker for Windows, the idea is that you'll have, when you install Docker for Mac, Docker for Windows, you'll have automatically set up a Kubernetes cluster that you can use for development. It's a single node cluster. It's a vanilla distribution of Kubernetes. So we don't add anything, we don't wrap it, we don't modify it, we don't fork it. We work upstream to fix the issues that we might find. And it's really something that you can use with any of your Kubernetes workflow. Okay? It will come bundled with the Docker CLI and Kube CLI. And when I say Docker CLI, it's going to be the CLI that you've got right now, but it's also going to be support for stacks, as we shown this morning. And you get all the nice features that you usually get with Docker. When you run an application and you expose a port, it would be exposed on your host. I mean, I don't know if you really realize that Docker for Mac, Docker for Windows, it's running on a small VM on your machine, right? And when you expose a port, it's exposed on the VM. But what we do with VPN Kit is we export it on the host so that you open your navigator and you just connect to localhost and boom, you're connected to your applications. We do the same with services that you can write in Kubernetes. I think it's pretty cool because it really makes your development workflow very seamless. You just code your app, build, deploy, test it, build, deploy, test it. It's very quick. The same thing that Docker for Mac, Docker for Windows brings you to the Docker platform, it will bring you to the Kube platform. I hope you're going to like it. And also, we've shown that we can support stacks natively. By stacks, I mean, you take a compose file that describes your application, all the services, and you're going to be able to run it natively on Kube. When I say natively, it's because we extended Kubernetes using API aggregation and custom resource definitions. So when your CLI sends a YAML file to the Kubernetes cluster, it's going to analyze it, it's going to convert it into replica sets, deployments, or maybe daemon set, or maybe stateful sets. It's going to create all the services that you need so that your application is up and running and replicates the same behavior that you've got on the Swarm platform. So this is really, we are really excited to give that to you. It supports updates, rollbacks, logs, scaling, etc. So I'm going to do a small demo. It's going to be taking the demo from this morning, but going into a little bit more details. Oops. How do I quit that? Yep. Yeah. So just to remind you, we had a compose file, and we have all the services, the web, words, DB. What I'm going to do is I'm going to edit it so that we don't have like 5 replicas, just to show you the scanning. So I'm going to build it. So when I build it, in fact, I currently talk to the usual Docker daemon because the images are shared between Docker, Swarm, and Kubernetes. It's the same images. So that when you develop, it's very quick. You just build, run, build, run, build, run. You don't have to copy images or whatever. So I'm going to deploy my application. So the messages you see right now, it's going to evolve in the future. We're going to map exactly with the same behavior as the usual Docker CLI when it talks to Swarm, because if you know the output from Swarm, it's not exactly that output. So just to show you that we've created really Kubernetes resources for you. So in fact, if you take a look carefully, one service in Swarm is mapped into one pod, one service, one deployment, and one replica set. And depending on the type of Swarm service, it can be a deployment, but it can be a daemon set. I don't know if you know what the daemon set is. It runs on all the nodes from your kube cluster. Or it can be a stateful set. As soon as you have volumes, it's really a stateful set because you need to, you really want to use that when you store data. So I'm going to show you that. Try to do something like that. Yeah. I don't know if it will be very easy to follow. Yes. I'm going to Docker stack scale, like 20 maybe. And so it's going to automatically create all the pods. Maybe it will, maybe not. Yeah, all the pods. Some of them are pending, some of them are just created. So all of those you just use the Docker CLI. I mean, you understood it from the keynote, but it is to show you that it's actually real. Docker stack logs. This one is a new command in the Docker CLI, and it will merge all your logs from all your containers. And if I access my application, I should hopefully see the logs updating. Oh, this one is nice. I can refresh it for hours.
This is fun to watch.
Yeah, that's about it. So really, I hope you're going to like it. I hope it will give you the opportunity to schedule your applications on Kubernetes, either using the Kubernetes specific native file format or using the compose file. We've heard a lot of people saying that compose files, they love it. They want to use it in Kube, whether it's development only or maybe even to production. So I hope you're going to like it.
Thanks, David. All right. Great. Thank you, David, so much. So in summary, what have we talked about in the What's New session today? We talked about Docker EE 17.06 and Docker CE 17.09 available now, and really a focus on scalable multi-architecture and a secure supply chain. We talked about our Kubernetes support, which is coming soon. Check out docker.com/Kubernetes if you want to sign up for the betas for either the EE cluster or for the Docker for Mac, Docker desktop projects. So that's production-grade Kube for ops with Docker EE. That's testing Kube apps on Docker for Mac and Windows for developers, and the ability to do a compose stack deploy for Kube workloads. Other sessions to attend if you're interested in this content. If you really liked what you saw with David's Docker for desktop stuff, check out the Linux Kit Deep Dive, which is today at 2 p.m. If you want to learn more about the advanced access control, such as RBAC for nodes and custom roles, check out the advanced access control session at 5:10 p.m. today. If you want a bigger overview of Docker EE as a product and a deep dive through the entire secure automated supply chain, my colleague Patrick Devine will give a talk at 11:15 a.m. tomorrow at the Docker EE product deep dive. And then finally, if you want to get an architectural overview of how we built the UCP Kubernetes integration and some of the getting into the guts of it, then go to the Gordon Secret session, which closes out DockerCon 3:45 p.m. tomorrow. So that's all we have. My name, oh wait, nope, two more things, sorry. If you want to try out EE, check out the hosted demo, docker.com/trial. Free 4-hour demo. It all spins up in the cloud, and it gives you the GA version of the product so you can walk through the different features. That's one. And second, if you are interested in modernizing traditional applications, stop by the booth at the MTA Pod. We've got a kit at docker.com/MTA. Look for an MTA roadshow near you, or contact your account team. I'll wait for the pictures on that one. And then, thank you. My name's Vivek, product manager at Docker. I tweet at the V Saraswat.
David, I'm an engineer. There's a lot of engineers from Docker here. If you can just stand up, they can answer questions for you. Please stand up, stand up.
A couple of folks.
Yeah.
So we're actually happy to take questions right now. I believe there's microphones on all three sides in the middle. So come up to a microphone and we'll take your questions or those questions. Oh. Can we get the handheld microphones on?
It's a trap.
No, not working.
Hello, hello, hello. Yeah, this one works.
Hi, about the new Docker version with Kubernetes included. You've talked about Docker for Mac and Docker for Windows, but what for Linux developer? We will have these features included in our Docker version or not?
It is in the roadmap. So our first target right now is to ship it for the desktop, Docker for Mac, Docker for Windows. So we should have a beta by the end of the year and release GA first quarter, and then we're going to work on Linux. Okay. It's really in the roadmap.
Yep. Another question over here. Maybe we should use the microphones too. Why don't you go first, and then we'll get the one on the right over there afterwards.
Okay.
Go ahead, you first.
All right, thanks, Vivek. Hello, David. I was wondering about Docker for Mac and the Kubernetes integration. Are you using Minikube behind the scene, or did you do another kind of integration?
It is using Linux Kit. So basically, in Docker for Mac, Docker for Windows was always based on the ancestor of Linux Kit. And in the latest version, we've reintegrated Linux Kit into the software. And right now, with Linux Kit, what we can do is we can start either a single engine or we can start a whole cluster, a single node cluster. And so we use Linux Kit. And given the fact that we use the same tools that we've used to build Docker for Mac, we are able to share files between the host and the cluster, which is quite complicated with Minikube, if I remember. You can expose the services on localhost. You don't have to use a Minikube CLI to get the IP or things like that. But some of the people who worked on Minikube helped us on building that, so it's only really going in the same direction.
Thank you.
Question over there on the microphone? Yep.
I have a question regarding how you are integrating certain Kubernetes features like service accounts and secrets. Do they map over directly from Docker secrets?
Yeah, so that's something we're looking at on the roadmap. So once Kubernetes has pluggable secrets as pluggable backends, then we'll look to make Swarm secrets available as a pluggable backend for Kubernetes. In addition to that, things like using a third-party product as well for secrets. So that is in the roadmap as well, but that's dependent on getting that pluggable feature into Kube.
Yeah, and until then, what we do is if you create secrets with Kubernetes, you can access them from a compose file in Kubernetes. Or if in your compose file, you describe the secret in a file, it will be created by the CLI so that you have access to your secrets.
Right, and about the service accounts?
So I'll have to take a look at the use case. We are looking at using service accounts within EE, but I can talk to you more about the specific use case there if you like.
All right, thank you.
Yeah. Next, do we have folks on the microphone over there? Oh, no, there.
Hello. Two questions. What about the integration of the Kubernetes UI in Docker Community Edition? Are there any of it?
Do you want to sponsor?
Is this in the CE or in the EE? Sorry.
In the CE.
Anyway, so in the CE, I don't think we have a plan to start it automatically. I don't remember. But it's going to be, you can run it, no problem. You can run it on EE or CE because it's a vanilla kube distribution. You can just run anything that you can run on Kube. And we're going to take a look if it's better to run it automatically on the CE. I don't remember the plan about that.
Yeah.
It works, but maybe it won't be automatic.
On the EE side, you'll have to do something around making sure the certificates play nicely. That's a slightly tougher question, but I believe it should work. But the goal for us on the UI side is to integrate sort of the Swarm and Kube workloads at the side by side in our UI.
How about adding multiple nodes of a Kubernetes cluster with a CE edition? Is that possible, or it's only single node?
It works in the lab.
Okay. Thank you.
Okay. Question over there. Is that right?
Check, check, check. So if I can choose now, should I focus on Kubernetes now? So will you kind of drop support for Swarm in like 2 years or so?
So let me make it clear. We don't have plans to drop support for Swarm, right? We're supporting both Kube and Swarm. There's certain workloads where Swarm makes more sense. There's certain workloads where Kube makes more sense. Our goal is to provide that level of choice. But we do want to make it clear. I mean, we have a lot of customers who are running in production on Swarm, and we have no plans to abandon them.
Okay, thanks.
One here.
I think that gentleman was waiting a little earlier.
Can you speak about the debugging experience? You mentioned that you now have logs integrated. So if I have an application running pieces of it on Kube and pieces of it on Swarm, I guess, or you don't recommend that?
So only some level of service discovery will make it possible, clearly. On C, I don't know the roadmap about that. Start simple. So I wouldn't recommend that as a first step. But since it's going to come for EE, it's going to come at some point.
But one question, I guess, is are the logs ordered already? So that if I see a log entry...
Oh, no. Currently, the logs assume that everything is running either on Kube or Swarm.
I see. OK, thank you.
Okay, question over there.
Yeah, here. Is it possible to use a CNI plugin I use for Kubernetes also with Docker Swarm in the future? So I have the same techniques from a networking perspective on both sides.
So right now, no, because it is opinionated in terms of network plugin. But as Vivek said, we clearly want that our users get the choice. So it will be for CNI and CNS. Yeah.
Yeah. So we're
not right now.
Yeah. So there is work on the east side to allow CNI plugins for networking, but the batteries included one will be CNI compliant, but won't be an external CNI. It will be our creation. Any other? I see a hand over there. I think.
So if I already have a Kubernetes cluster running, how can I integrate with this new Docker thing? How this play out?
Good question. So we need to solve. It's a little bit linked to can I use those features on Docker CE on Linux? It's clearly on the roadmap. You know, the Docker for desktop, it has a mixed model where we have lots of closed source components, and some of the components are open source, like Linux Kit, VPN Kit, Data Kit, etc. So we are still trying to find out which component we want to open source, and it will be in the CE story on Linux. So maybe you should be able to use them on your own managed Kubernetes cluster. But right now, we really focus on developer experience and production with EE.
Yeah, so on the EE side, because it is an opinionated stack with batteries included parts, UCP will create the Kubernetes cluster for you in the beginning. We are investigating how you could install it on top of an existing cluster, but that'll be roadmap work.
Great, thank you.
Any other questions? Raise your hand if you have one. Yeah.
So when using the Docker Compose, can I have multiple containers in one pod?
Not yet.
Thanks.
Any other questions? One more over here in the middle.
Get a mic behind you.
Don't make Ben run around so much.
Hi. Can I inspect the manifest file when I use the Compose for deploying Kubernetes?
Can you expect, sorry, what?
Can I inspect the manifest file, the YAML file for Kubernetes when I deploy from Compose?
Yes.
Okay.
We introduced the stack object. So it's really a custom resource definition. So you can using kubectl, you can query the status of your stack, you can query the spec, etc. So.
Any last questions? Great. Well, thank you very much for coming. Appreciate it. And we'll be up at the front if you want to ask any more questions here. So thank you.
Thank you.